The topic we'll be discussing in this lecture is reverse tunneling. So previously we have discussed tunneling and encapsulation. So tunneling will be done whenever there is a packet is to be transmitted from HA to COA. Similarly, whenever the mobile node want to communicate with the correspondent node, there should be a reverse tunneling from COA to HA. So why it should be done? So why can't the mobile node can directly communicate with the correspondent node if the mobile node knows the correspondent node's IP address? Why the reverse tunneling should be done? If reverse tunneling is not done, then what are the problems that it will create? That first we will address. Okay. So first we will try to understand the need for reverse tunneling, and then we will see how reverse tunneling works. So if reverse tunneling is not used, then we'll face typically some problems. What are they? First is almost all companies and many institutes they use network firewalls. They use network firewalls to protect their internal network or intranet from what you call from attack or from external attack or whatever it may be. Okay. So any data that pass through the that comes to their local network or the intranet should pass through the firewall. Should pass through the firewall. Okay. So firewall should ensure that only authorized data and only confidential informations were passed through the firewall. Okay. So it ensures that no malicious act is being taken is taking place. Okay. So the firewall basically provides a simple protection to the intranet. Okay. Now this firewall, because of this firewall is also one of the reason why reverse tunneling cannot be done. Okay. So let us discuss that. I'll try to explain that. So assume that there is a mobile node. Currently, it is available in a foreign network. Okay. Let us assume that the mobile node is currently available in a foreign network. But originally, the mobile node belongs to some other home network. Originally, the mobile node belongs to some other home network. Okay. Now, now let us see. There is a firewall in this home network. Let us call it as firewall 1, and there will be a firewall in this foreign network. So let us say it is firewall 2. Okay. So we are discussing why reverse tunneling is required. Why not the mobile node can communicate directly with the CN. Okay. Let us assume CN is in the home network. Correspondent node is in the home network. Now the mobile node want to communicate with this. Okay. Now what happens in the sense here, the scenario, the mobile node when it sends a packet, every packet will have the source IP address and the destination IP address. The source IP address of the packet is originating from the mobile node. So the source IP address will be its fixed IP address. The source IP address of the mobile node will be its fixed IP address. Okay. So what is its fixed IP address? Its fixed IP address is nothing but the IP address what it have when it is in the home network. With that IP address, it will send the packet. With that IP address as the source IP, it will send the packet. Okay. Suppose if it sends a packet like that, then what happens in the sense? First of all, this firewall will not allow that. The reason is it is not topologically correct IP address. It will not be a topologically correct IP address because because the packet says that it is originating from the foreign network. Maybe foreign network may be using some other subnet, but this mobile network it is using its fixed IP address. It may be following some other subnet. Okay. For example, this home network subnet may be 129.48.56.0. Okay, whereas this foreign network subnet may be something else, maybe 132.146.221. Okay, now this IP address of the source IP will follow this pattern. So which is not a topologically correct IP address in the foreign network. So at the first place, this firewall won't allow that communication. Okay, but assume that this firewall has allowed, or there is no firewall here, then in that case the data will come here. But again, this firewall also will not allow. The firewall in the home network also will not allow. Why it won't allow? The reason is someone outside the network. Mobile node is currently outside the this particular network. Okay, this particular intranet. Someone outside the intranet is sending a packet with an IP address that belongs to an system that is inside this particular intranet. Okay, so this firewall, what it will think, in the sense, it will think that it is an attack. Is an attack. Somebody is trying to pretend as if they are communicating within the network, and they are trying to cheat the firewall. Like that, this firewall will think, and it will not allow that communication. Okay, so the point here is not only the destination IP address, but the source IP address also matters. So this is the main reason. So this is one of the reason why directly the mobile node cannot communicate with the correspondent node. Okay, because of the firewalls. So this is one of the reason why reverse tunneling is required. Okay. The second reason is, say the mobile node wants to multicast the packet. Multicast means it wants to send the packet to a group of users in the home network. But currently the mobile node is in the foreign network. Sitting in the foreign network, the mobile node want to multicast the packet to few nodes in the home network. But that is not possible. By being in the home network, by being in the foreign network, the mobile node cannot multicast the packet in the home network without using reverse tunnel. Okay, so if it is not using reverse tunnel, and if it want to do multicasting by staying in the foreign network, that is not possible. Okay, so if the mobile node want to do multicasting, then reverse tunneling is required. That is the second reason why reverse tunneling is required. Okay, I think it's clear. If the mobile node is in the foreign network, and by that time, if it want to multicast packets to the few nodes in the home network, then it is not possible without using reverse tunnel, without using reverse tunneling. So that is the second reason why reverse tunneling is required. The third reason is, every packet will have a TTL, time to live. Every packet will have a TTL, time to live field. Okay, so assume currently the mobile node is in the home network. If the mobile node is in the home network, so the mobile node's default location is home network. Okay, when the mobile node is in the home network, the value of the TTL will be very low. The value of the TTL will be very low, because to ensure that the packet is not going somewhere out of the range. Okay, somebody should not unnecessarily receive that packet, and thereby it should not create any issues. Okay, so generally the TTL field will be low. Okay, but now assume that if the mobile node is moving, and now it is connected to a foreign network. No more the mobile node is with the home network. Now it is connected with a foreign network. Okay, and now it wants to send a packet to the home network. Now it wants to send a packet to the home network. Now if it uses the same TTL, if it uses the same TTL as whatever it is using when it is in the home network, if it uses the same TTL, then what will happen? This packet will not reach the home network at all. Before it reaching the home network, the TTL will expire and the packet will be dropped. Okay. And because of this reason, if the mobile node increases the TTL value, say assume that the mobile node, so otherwise the packet will be dropped because TTL will expire. So because of that, if the mobile node increases the TTL, then what will happen in the sense, uh, then then there is a issue called the mobile IP will no longer be transparent. Then the mobile IP will no longer be transparent. If you adjust the TTL, if the TTL is adjusted whenever the mobile node moves to a foreign network, then the mobile IP is no longer supporting transparency. Okay, then by seeing that particular TTL field, some attacker or somebody else will understand whether the mobile node is currently in the home network or a foreign network. So this is also not suggestible. Okay, so it means that we don't want to increase the TTL value, but still, when the mobile node is in the foreign network, it should be able to send packet to the home network. So that is also possible by tunneling. That is also possible by tunneling or reverse tunneling. Because in a tunnel is just considered as one hop. A tunnel is just considered as one hop. Whenever a packet passes through the tunnel and it comes out of the tunnel, it is just considered as one hop. Okay. Actually, it may pass through hundreds or thousands of nodes through the tunnel, but logically, it will be counted as only one hop. So tunneling, so the reverse tunneling will solve this problem also. Okay. So these are the three reasons. The first is the issues created with firewalls. The second is the multicast, and the third one is the we don't want to adjust the TTL value when the mobile node is moving. Because of these reasons, we are going for the concept called reverse tunneling. And reverse tunneling was specified through the RFC 3024 request for commands. Okay. So originally the mobile IP without reverse tunneling, that is called as RS2344. After adding reverse tunneling, it is called as RFC 3024. Okay, fine. So now let us see how the reverse tunneling concept works with a particular diagram. Here you can see this particular mobile node, it wants to communicate with the correspondent node. So when it wants to communicate with the correspondent node, first it sends the packet to the FA. So this mobile node is registered in this foreign agent. Okay. So it is sending a packet to the FA. So in this packet, so it sends a packet. For this packet, the source IP address will be mobile node's IP address. Okay. And the destination IP address will be correspondent node IP address. Like that, it will send a packet to the foreign agent. Now the foreign agent, what it will do, it will encapsulate this packet in another bigger packet. It will encapsulate that particular packet in another bigger packet, and for this bigger packet the source IP address will be FA, that is foreign agent. Okay, and the destination IP address will be HA, and the destination IP address will be HA. Okay, inside that, inside this bigger packet, the packet that was sent by the M1 will be encapsulated, which has the source IP address as M1 and the destination IP address as CN. Okay. Now for this new packet, uh, this is the these two things are the header, and this is the actual date of birth. Okay. And this packet will be transmitted to HA. Okay. Now HA will decapsulate this packet, and this packet will be transmitted. The packet, this encapsulated packet, will be transmitted to HA through tunneling, through tunnel. That is, it will be just considered as one hop. So there is one hop communication from M1 to FA, that is one. The second hop is from, sorry, one hop from M1 to FA, foreign agent. The second hop is from FA to HA. But actually, this is a tunneled communication. Internally, it may communicate through several nodes, but logically, it is treated as just one hop. Okay, now the packet reaches HA. Now HA decapsulates this packet and it will identify, so it will remove the header, it will remove the external header, and it will remove the packet which is present inside. Okay, and it will understand that the destination address is CN. So then it will forward the packet to that particular destination address in step 3. HA will forward the packet to the CN. Okay, so this is how this problem is solved in with reverse tunneling. Okay, right? So this is how reverse tunneling works, right? So router accepts only topologically correct IP address if there is a firewall. Okay. Now the packet from M1 encapsulated by the FA. M1 sends the packet, but FA encapsulates it. So as the FA is encapsulating, now it becomes topologically correct IP address. Now as FA encapsulates, it becomes topologically correct IP address. Okay. Otherwise, it is not a topologically correct IP address. I think you are getting the point. Initially, the source IP address is M1, but when the packet reaches FA encapsulate the source IP address is FA. So it becomes topologically correct IP address. Okay. Further, multicast and TTL problems are also solved because now we are using reverse tunneling. So multicast problem is solved. TTL is also solved because the entire tunnel is considered as only one hop. So there is no problem with TTL. But there are certain issues which reverse tunneling does not solve. Okay. The reverse tunneling can be abused to circumvent security mechanisms in tunnel hijacking. Okay. So this is one issue with reverse tunneling, and the reverse tunneling is backward compatible. That is, the extensions can be implemented easily with the current implementations without these extensions. Okay. So it is backward compatible. Okay. So the without reverse tunneling also, if there are systems without reverse tunneling that can work fine, that can work fine with reverse tunneling system. Okay. So that's it about reverse tunneling. So what we have discussed in the sense, what is the need for reverse tunneling and what are the issues we will face if reverse channeling is not there, and then we have discussed how the concept of reverse channeling works. Okay, fine, let us stop here. Thank you.